Hello to all. Today I'm gonna show you how you can implement the propulsion block into your model. Uh, Today we will use HL20 airframe and the controller model. It's a standard model. You can find the help module on the Matlab. If you write HL20, you can find the NASA HL20 model. It's a very basic model, but a very informative model in here. Yes, as you can see in here, trust is 000, but we will change this trust. It's not connect, but normally if you open the model at the first, you can see the connection between the model and this block. In this block, we will add the propulsion block. In this model, we will add the propulsion block. That's the main structure of the dynamic model. It's a standard, it's a standard blocks, and just we will add the truss section in here. Normal truss section was 000 x y and z direction. In the turbofan engine system, in this block, we have taken the just x direction. That's why we have taken just one value. Normally, in a model, you will take three different values: x direction, y direction, and the z direction. But in this model, we have taken the just one direction, fx. Yes, we have three input parameters and two output parameters. These three input parameters, first one is the throttle position. If you look at the HUD module, you will see the range of the throttle 0 to 1. I choose for trial 0.5. It doesn't matter for this trial, but it does matter your designs. You have to decide that. And the Mach is coming from the aircraft body. It's coming from the aircraft, and the engine will decide the force after that. And the altitude. Altitude in here it's meter, because we are using metric system in our model. You can find the English system also, but I prefer to use the metric system. Initial thrust means idle. You can decide just idle, but you can accept like that at the beginning case. The maximum sea level static thrust, I didn't make any change. The other things are also constant, but you have to change this value according to your design. Also, this is turbofan. Normally, we have to use a jet engine in this spacecraft, but it's just for trial. You can easily modify the turbofan engine system to jet engine system. After that, if you want, we can talk about that. You can easily find some articles how you can change the turbofan to turbojet or the turbo shaft. You can find some articles on the academic research. Yes, the equation of motion block, it's a standard one. You can also find this block on the Matlab. We have taken the Earth positions from this block, but normally Earth axis and the body axis it's contradict each other for about z-axis. On the Earth axis, we have taken z distance as negative, and we have to turn it the positive, and that's why we can get the height above ground level value, and we can feed this value on our turbofan model. But you are wondering, I know, in this model we have made our test on sea level. Sea level is our ground level. There is no difference between the sea and ground. That's why our high level, ground level, and the pressure altitude, it's the same. And also the equation of motion block using the metric system. That's why we have taken our output value as meter, and we can directly feed the model. Yes, the output parameter is the thrust. Thrust is as I have mentioned, is just on the x-axis. The other axis are 0. And in the Newton, the another output is fuel flow. It means fuel consumption, actually, the kilogram per second. Our model is very basic and very simple. That's why we don't need to use the fuel consumption, but we can use just for information. And that's all I want to say. We can run our model, and we didn't take any error. That's good. You can see just fuel consumption. It looks good. It's a very simple explanation. If you have any further question, you can ask me directly. Thank you very much for listening.